Hey everyone, today I'm going to be wiring up some outlets and I figured I'd show you how I wire outlets, and it's pretty straightforward, but I'm going to show you three different styles. One is a GFCI single location wiring configuration. I'm going to do a GFCI with a pass-through so everything else on the circuit is protected, and third I'll just do a standard outlet. So first thing we do is we make sure the power is off. I got a little tester here, and I already know the power's off, but this is technically my hot lead, but it doesn't matter for this particular case. So we start by stripping our wires back. I like to do this with a utility knife very carefully. I've sliced my fingers countless times in the past, so I try to be very careful with cutting the outer layers off of this. So we remove our, after we got the outer layer, we remove our paper cores, one that surrounds the ground, the one that surrounds everything, and then we cut our outer layer off as far into the box as we can. And we're also being very careful not to actually nick our wires inside the box. Alright, so we've got our two sets of wires. Black is our hot. Bare wires are ground, and white is our neutral. So we're going to take wire strippers and strip all these back. Can't remember if I ever showed these wire strippers before. They're made by Milwaukee. These are really nice wire strippers, automatic strippers. You basically set your depth with this little stop here, and you put your wire into the stop, squeeze, and it automatically holds onto the wire with the left side. The right side has a little cutter that comes down and then strips it off. Not sponsored, but again, these are really nice strippers. So, all right. So next, we need to tie the two grounds together. So what I like to do is I like to take a little off cut of wire, and I will, if these are flush on both ends, I usually will use a pair of needle nose pliers and push on them a little bit to get them to push through the other end, and then they will just pull right out. So we're going to use just a Wago connector and insert all of these grounds. And you can see inside the connector that they're all bottomed out and the lever is closed. So I'm actually going to move some of these wires around a little bit. There we go, just to make it easier to push this into the box. And then we basically just fold all this into the box as deeply as we can. We have our remaining ground sticking out to connect to. So for the GFCI, for this particular unit, I just want this particular outlet to be controlled by a GFCI, but if this one trips, I don't want it shutting off the rest of the circuit. So there's two ways I could wire this. This particular outlet actually has two spots on both the line and the load, so I could put both of them under the line. And that would be one option, but I am going to do it slightly different. And this is largely to make future maintenance a little easier, is I'm going to tie all this together similarly to how I did the ground. So there's only one wire coming out of the outlet. So I'm just going to strip back those other pieces of wire that I had, and that did not work great. That will happen sometimes with the automatic strippers. It will pull on the inner wire and move the entire jacket on short lengths. So let's see if I can pull this straight. Kind of going. Oh, there it goes. And I pulled it too far the other way. Got it fixed. Alright, same thing as before. We're just going to put Wagos on. I hear an ice cream truck. That's kind of cool. I'm gonna go check out the ice cream truck. I'll be right back. Alright, that was, I've seen that ice cream truck before. I consider that the sketchy ice cream truck. It's basically a pickup truck with a freezer on the back and a bell on the top. So anyway, back to our project here. So I got these all connected, and again we're going to just push all this into the back of the box. Sometimes this is the hardest part. Getting everything tucked in. Okay. So now we have everything nicely tucked in. And I like to start with the ground. So the ground goes to the green screw. So we make sure that we're connecting to our line, and the white goes to the silver screw. It's nice and tight. And lastly, our black goes to the copper screw on the line. And the reason I'm using GFCIs with screw terminals rather than those Wago style levers is because I just have a whole bunch of them. Alright, so this is all connected. Again, both of our on the line side. And we just need to tuck this into the back of the box. And screw it in. Particular outlet is missing its plaster ears, and the reason for that is because I got a bunch of these GFCIs as customer returns in a lot on eBay really cheap. So in this particular application, it doesn't matter that it doesn't have plaster ears. But there's also a chance that this outlet could be bad and we're going to have to replace it. But that's one reason why it's nice to only have one set of wires to have to disconnect and reconnect if that's the case. Alright, so now if I go and turn the power on, we can check this outlet. Do the test. Yeah, passes the test. It resets. And we are missing the neutral. That is incredibly weird. I wonder if that's because of the way... No, that can't be. All right, well, let's pull that apart and check it again. Let me shut the power off. It's possible our Wago became disconnected, or this outlet is bad. Oh, our Wago looks okay. Let's try that again. All right, so let me go get a power meter and we'll check that in a different way. All right, so I got my power meter. I have it set to 200 volts AC. And if I touch it to both the neutral and the hot on each side, it tells us we have 120 volts. If I touch it to that, to ground, it should tell us 120 volts. And it does. So this tells me that this is a bad outlet. So someone actually had a valid return. So let me shut the power off and we'll swap that outlet out. I suppose there's also a chance that my meter could be, my tester could be reading something weird, but I don't think so. A little bit of an awkward spot here. Sorry if my head's in the way. sure my connections are nice and tight. And we'll leave this one out of the box. Test it. Reset. Yeah, there we go. And if we hit the test button, it trips. So let me shut the power back off, and I'll put that outlet back in the wall. One more time, we'll check it. And we're good. Hit the test button, hit the reset button. We're good to go on this one. And our little light's on. So as for this other GFCI here, I'm gonna pull the screws out of it because sometimes I need to reuse those, and chucked in the bin. So let's move on to this outlet. Grab my tools. All right, so we have that power on, and we need to do that for this one because we need to find out which one's the line and which one's the load. So I believe it's this one. Yep, that's the hot. That's the line. And this one will be off because it's just picking up some residual. That's the actual hot. These continuity testers aren't perfect. So that's our line. So now we need to shut the power off. In order to see some, so yeah, oops, let me put it back on. So now it's off. So to save some time, I already did our ground. And in this case, we're going to utilize both line and load on GFCI. So if you look at the back of these, it does clearly say line and load. Again, the brass terminals go to the black, and it also says hot on the back here, and the silver terminals go to white, and it says white on the side here. So, and the bottom is ground. So again, we're just gonna hook all these up. So the top is line. And now we're going to hook up our load. I'm just going to make sure these are all nice and tight. And since we had a failure on that other one, before we shove it in the box, let's test this. So we're going to be very careful not to touch the sides, only the top and bottom here. We're going to hit reset, and both work. Test works, reset works. Perfect. Let me shut the power back off and I'll shove that back in the box. So what I usually like to do is kind of twist everything into a circular motion. shoved in there. And then I'm trying to be mindful of where the ground is in relation to everything else. And I want to kind of push the ground behind everything so it doesn't short out against the sides of these terminals. I think we're good here. And that should be good. All right, one more to go, and this will be our standard outlet. So for this one, again, for this particular case, it doesn't matter which one's hot or neutral, or sorry, hot line or load. And I want to show you how quickly things go with these lever nuts. Watch this. So ground goes to green. White goes in there. White goes in there. Just routing wires. Black in there. Done. Another trick I like to use is to push everything in the box. I will tilt my outlet a little sideways so the screws kind of just go into the side, and you push everything in. That'll set the depth of the wires. And then you pull it out slightly, twist it a little, and line up the screws. Because I've had cases where if you try to rely on the screws pulling the outlets in and shoving all the wires back, if for some reason there's not enough room in the back of the box, it will either cause your outlet to tilt side to side, or it will even potentially strip out your screw holes for your outlet, or break the outlet even. Okay, so this circuit should be all done. Let's turn the power on. And there we go. So we have these outlets here. So if I trip this one, it shuts that off. And everything else down the line, there's actually a couple more outlets. So there's these two outlets, which are also down the line from that one. So these four outlets, let me zoom you out. I really need to back up here. All right, these four outlets in this one room are controlled by this GFCI right here. And we'll just always check your work and make sure everything's working as it should. Top and bottom's good. Top and bottom is good. Top and bottom is good. Top and bottom is good. And we've already determined if we test here, reset, all of those are working. And on this one over here, test and test. So now if I trip this one, the rest of these other ones will stay on because of the way we wired it. And the reason I wired it this way is because I envision this room being like a potential workshop or storage area. And if someone trips a GFCI in here, there's going to be, I don't want them to have to walk all the way over here to find the GFCI to reset it. And this one here, I want it to be GFCI protected because it's in the basement. But this I envision mostly being for like servicing the furnace. It's for the technicians. So, and if they trip that one, they can just reset it right there. So that's what I have for you today. Thanks for watching, everyone.